Hello everyone. For the past 3 years I have been designing, building, testing, crashing, and redesigning this right here. This is the Tubular Quad version 4, and this is my own FPV Miniquad frame that you can build at home without a CNC machine. So in this video, I'm going to be talking about my philosophy behind this design and all of its design features and all of the changes that have been made for this version. But first, let's see how it's made. Okay, I hope that you guys enjoyed that build montage. Now let's go ahead and talk about the philosophy behind this overall concept, the design itself, and all of the revisions that I've made for this, which is the version 4, and some of the manufacturing tricks that I've used to build this thing without a CNC, and then how you could build this at home. So, to talk about the general idea behind this frame, I need to go back in time and talk about the frame that I used to run before even designing the version 1 of this. And that frame was the Impulse RC Alien. And the general formula of the Alien you still see around today. It is a pretty good formula, and some people even run the Alien itself today, but there are some problems that I personally have with it, and I personally saw room for improvement with this frame for what I want out of a frame. So first of all, this frame you see right here is a 5-inch, and I prefer 6-inch. Now, yes, this frame was offered in a 6-inch, but that brings up a good point, which is that there are a lot of great 5-inch frames that are not offered in the 6-inch size, which is one of the reasons why I ended up designing the tubular quad. Another thing about this frame is that it is a Squash X design, which means that the distance between the motors front to back is less than the distance between the motors side to side, and this just makes the pitch authority a lot worse than the roll authority. Another thing is that this fuselage is relatively long, and so the battery goes on like this, camera goes on like this, and all this mass is distributed across a rather long distance, and that further reduces both the pitch authority and the yaw authority of the quad. And lastly, this frame in particular is pretty heavy. So those are the problems that I personally have with this formula. And now let's go ahead and talk about how I addressed those problems with the concept of the tubular quad. So first of all, this frame supports 6-inch props, and there is space between all of the props so that the props have room to breathe, which makes the quad feel a little bit better. In addition, it is a true X design, so the distance between the motors front to back and side to side is the same, which gives for a more consistent control feel between axes. And you can see that the fuselage is a lot shorter than the Alien. So the battery actually goes on sideways, toilet tank style, and the GoPro goes on somewhere here. And you can see that the mass is in a really tight ball in the middle of the quad, which really increases the control authority of the pitch and yaw axes compared to the Alien style frame. And the last thing about this frame is that it is really light. So as you see it right here with all the hardware, including the motor screws, it weighs less than 100 grams, 99.8 grams, which I am really happy with. To give you some perspective, the Hyperlite Glide frame, which is one of the lightest 6-inch frames on the market, in the same configuration with just the carbon and the hardware, including the motor screws, weighs 114 grams. So the quad that I designed and built is 14 grams lighter than one of the lightest frames on the market. So that is kind of the general concept behind this frame. Now let's talk about the design details and what I've changed for this revision. Now, the standout feature of this quad is the tubular arms. And originally, I used tubes for arms just because it was something convenient to make arms out of. But it turns out there are a lot of benefits to using tubular arms over flat carbon arms. The first benefit is that a circular profile moving through the air is a lot more aerodynamic than a rectangular profile moving through the air. Another benefit is that tubes are a lot better at resisting a bending force than just a solid shape. Another benefit of tubes is they are much stiffer than just a solid piece of carbon or flat carbon plate arms, and this is something that I think a lot of people overlook when it comes to frames, because the stiffer that your frame is, the higher its resonance frequency is going to be, which means it's going to naturally vibrate at a higher frequency, which means your flight controller is going to have a much easier time filtering out those vibrations, so you can run less filtering, and that will subsequently make your quad feel better. And the last benefit of these tube arms, and my favorite benefit, is that you can run the motor wires through the arms themselves, which makes it really clean aerodynamically and also just really clean to look at. So this is the version 3 of this quad, and you can see that The motor wires are completely tucked. It looks really good. And a side benefit of tucking these wires is that your propellers have no way to chop your motor wires. So the tubes used on the version 4 are 12mm outer diameter, 10mm inner diameter, all the way up until about here, at which point there is a smaller 10mm tube glued inside of the 12mm tube to double the thickness of the tube for the screw holes, because where the screw holes are, there is a lot more stress. The motor mount is a flat carbon plate with little flanges on the sides that have carbon toe wrapped around them, and then there is epoxy laminating resin soaked into that toe, which makes it so these things are not going anywhere. This is the same exact motor mount design that I upgraded to during the version 3's life, and these are just really strong. The previous motor mounts that I had were these, which you can see is just a flat carbon plate slapped on top of the tube, and then the motor screws actually go through the tube and the plate. The problem with this is just slapping the plate on top is just not strong enough, which is why the screws have to pass through both the tube and the plate to give extra strength. But even then, it really wasn't strong enough. So this is a much better design, and some things that I can do now is because this is so strong, the screws can go off to the sides instead of through the tubes, which means I can use shorter screws, which reduces the weight. And since there are no longer holes in the tubes here, there are no longer the stress concentrations associated with holes, which means that I can run that thin thickness of tube for this entire distance, which decreases the weight of the arms and makes it so this quad can respond really quickly. So moving on to how the arms are mounted, this is the biggest change that I've made going from the version 3 to the version 4. So let's take a look at the differences. So here on the version 3, you can see that the bottom plate is basically a rectangle, and we have our 4 outer screws, which are also the stack screws, and then these 4 inner screws, which are all crammed in the middle. And I also attempted to make the arms touch in the middle, which didn't go so well. And also I did have an arm break on this quad, so I didn't think it was totally unreasonable for this arm to break in that crash, but I figured I might as well attempt to make the arm mounting stronger for the next version. The version 4, you can see that the bottom plate is no longer basically a rectangle. It extends outwards because we can see that I basically moved these inner screws to the other side of the stack screws. So now these stack screws are the innermost screws. What this does is it decreases the length of the arm so that any force imparted on the end of the arm is going to have a shorter lever arm, and therefore will induce a lower stress on the screw holes. Another thing that I did is I made the distance between the 2 screws slightly further apart, which reduces kind of the couple moment effect here and further reduces the stresses. And lastly, I have given up on making the arms touch because to do that by hand requires way too much precision, and on the version 3 they didn't really touch at all. So now that the arms are shorter as a result, it's going to be a lot easier to run all the motor wires because we actually have some space to work with, whereas on the version 3 there's like no gap in there to work with, so it was pretty brutal putting the version 3 together. Another change to the bottom plate, other than having it have these wider sections, is that the cutouts are now different. So before they were triangular cutouts, which you would think would be stronger. However, those triangular cutouts only make it strong in resisting bending in this direction, but that's never how bottom plates and top plates fail. They always fail from bending in this direction. So in that case, it really only matters how much carbon is there, and it's about the same amount of carbon that is there between the version 3 and the version 4. So we really shouldn't have any strength issues with this new bottom plate. This makes the manufacturing of this a lot more simple. So now there's only 4 cutouts on the bottom plate instead of 8. And then lastly, you can see that the carbon runs front to back and then left to right. And I've kind of left solid pieces where those fibers are running. And I've left the middle pretty solid as well, just to make sure that these arms really have something solid to mount to. For the mid plate, I've actually cut it out so that the fibers are running 45 degrees oriented relative to the bottom plate. So the fibers for the mid plate are actually running this way and that way, which is what you want based on this shape. So it's basically an X now. Before it was just a square. And I am also using the threaded inserts that you see on a lot of other frames. They work great. I have no problems with them. So I've used them on both the version 3 and the version 4. And all that's basically left is the top plate. So the dimensions of the top plate have stayed the same. The only thing that's changed is that the cutouts are different. So we have 3 main cutouts instead of 8 main cutouts on the previous one, which once again makes it way easier to manufacture. And then obviously we have our little slots for the battery strap. So battery goes on right there. And then some room up front for the GoPro mount, which goes on something like this. And something to mention is that because these tubes are so tall, I'm actually using 35 millimeter standoffs, but it still gives this frame a slammed stance because of just how fat the tubes are. So the props are pretty much in line with the top plate, which is what you want for a good weight distribution. And a side effect of that is you have a lot of space in front of and behind the flight controller for electronics. So you can fit a full-size camera up here if you want, and then you have plenty of space in the back to stack things up. So in the version 3, you can see that I have a receiver, the video transmitter, and then a fat capacitor that all fit in there just fine. And you wouldn't have that kind of room in something like the Hyperlite Glide where the standoffs are a lot shorter. And this kind of makes up for the fact that this fuselage is really short. So even though it is a relatively short fuselage, you still have a relatively large amount of room to put all of your electronics. And the very last thing to mention about this quad is that all of the carbon plate components are the same thickness at 2 millimeters thick. This is a very common thickness you'll see on most commercially available frames. It is what I used on the version 3 and I had no strength issues with that. So I have maintained that same thickness for the version 4. And that also makes it easier to manufacture. So now let's go ahead and talk about the manufacturing tricks that I've used to avoid using a CNC machine to make this thing. So the first thing that I've done is I've used my 3D modeling program to make a drawing with all of the flat carbon components at 1:1 scale. So that way I just print out the drawing and I have a template that I can glue onto my big piece of carbon plate. And on that drawing, I've marked the centers of all the holes and things like that so that I can drill all the holes precisely, and then I can cut out all of the pieces. The other trick I've used is actually using a 3D printer to make a whole template for the ends of the arms in here. And this is something I did on the version 3 and I had a lot of success with it. This time I actually ran into a hiccup. So what happened is I took a little bit of thickness off in this gap to make this little jig clamp more securely on the end of the arm. However, that caused this surface and this surface to become warped, so it didn't sit on the drill press table very nicely, and it actually caused one of the holes to become off center in the template. So one of the 4 holes in all of the arms is slightly off, so that was the one hiccup that I ran into while building this thing. But I went ahead and updated the 3D files so that if I have to make new arms at some point, I won't run into that issue again. So if you want to build one of these for yourself at home, what do you need? I would definitely say, first of all, you need some kind of rotary cutter. This thing saved me so much time cutting out all the holes, just cutting out the plates in general, getting everything close to the line of the template. And then you'll need some sandpaper and some files to bring all the parts all the way up to the line on the template. So you did see that I used a sanding disc to kind of speed up the process, but you can just use sandpaper and files. That'll work just fine. You also probably want to be using a drill press to drill all of the holes, because the placement of the holes is really critical to get everything to line up properly. So I don't think using a hand drill would cut it. Probably the least accessible tool you're going to need is a 3D printer to print out this jig, which I think is kind of necessary. So if you don't have a 3D printer, you know, maybe you have a friend that has one, or you can pick up 3D printers relatively cheap nowadays, but you know, that is something to consider. Overall, I think all the tools you need are pretty simple and reasonable, relatively speaking, especially compared to CNCing a whole frame out, which you could do with this frame. I've tried to design it in a way that is not too hard to cut out by hand. Obviously, I did it myself, so I think you can do it as well. If you're interested in this frame and you want all the files, usually I would share all the files in a Google Drive link down in the description below, but this time I'm going to try something a little bit different. So what you can do is you can head to my channel, go to the About page, and if you scroll down, there should be an email address where you can reach out to me and I'll be happy to send you all of the files. And that way I can connect with you guys a little bit more and also answer any questions you have and help you guys out along the way if you want to build one of these yourself. So once again, feel free to send me an email. I will be more than happy to share the files with you. So in the next video, I'm going to be installing all the electronics from the version 3 onto the version 4, and I'm going to be talking about my electronic setup because there are particular reasons why I'm running all of the electronics that I am running. So I am really excited to get this frame up in the air, and I hope you guys are excited to see more of this content. So please like this video if you liked it, subscribe if you're new, and thanks for watching.